Come up and grab a piece of paper, ladies and gentlemen. You're going to need it for what we're going to do at the start today. So let's go, let's go, let's go. I would go with the big. I would go with the big. Don't let him in. What you doing? How am I supposed to keep people out if you keep opening the door and letting him in?
Oh, wait, what are we getting? Oh, piece of paper.
Way to go, Michaela. Really next thing you know, you'd be opening it up if it was Michaela at the door.
Absolutely.
I wouldn't.
Like one of each. Is this what we get for church?
Dante.
I know.
You know, but you're still doing it. So what does that mean? That means either you don't care.
I'm trying to hurry up.
Do you guys need any highlighters on here? Andy? You need a highlighter? Okay, grab a yellow one.
Isaiah. No. Michaela, no. Lucia. Jasmine, yes. Rose, yes. Mason, yes. Evan, yes. Where's Evan? Andy, yes. Anthony, yes. Ben, yes. Anthony, no.
Dude,
17. Okay. Okay, ladies and gentlemen. Couple of things. Okay, my turn for a while. Declan, zip it. Okay, so couple of things, ladies and gentlemen. Number one, we are getting down there. We are under 3 weeks until our final exam. Okay? Today we are going to talk about ternary compounds with prefixes and suffixes. Okay, we'll explain to you what that means. Again, I'm still missing one of my calculators. If it doesn't return by the end of the day today, I will simply put them away and you will not be able to use them. Okay? You should have grabbed a piece of paper so that we can practice before we get into today's lesson. And on Friday, you will have a quiz, ladies and gentlemen. Probably next week, Wednesday, you'll have the test on this unit. The quiz this week will cover all ternary compounds, meaning the ones we've been doing, the ones we will introduce today, and then the binary covalent compounds that we will introduce tomorrow. So we will not put acids on it for you. Just so you know, ladies and gentlemen, I have a student who is taking the class kind of as an independent study. So I've been taping our lessons in the morning. So what I do is I videotape everything that I'm going over, everything that I'm writing on the screen for them. So I decided that as long as I'm doing that for them, I will put it out there for all the students because there's been some of you who have been absent lately. So if you go into the classroom stream and into the classwork tab, ladies and gentlemen, Unit 3 class teaching videos. If you go on to this, it's a document there. And every date is a YouTube video, ladies and gentlemen, with what we do in class. So if you missed the day about binary ionic compounds or ternary or whatever, you can go through and you can watch the video if you want. It is 100% your choice. But again, I don't seem to get a lot of people who are coming up to me and asking me for help. But on the quizzes, some of the scores aren't the greatest. So if you want, you can do this. And then tomorrow or after today, when the video is done processing, there'll be a link for today's lesson as well, and I will try to keep this up for each day in this unit for you. Questions? The other thing is I realize that sometimes people have a hard time finding the keys for the worksheets because I put them into the daily agenda. So what I did is I made a post, ladies and gentlemen, and attached to that post are all the keys for the unit for the different worksheets that we will be doing. So that, again, if you're working on a worksheet, rather than do it all wrong and then realize, oh my gosh, I don't know what exactly I'm doing, you can use the keys to check how you're doing after a section, see how you're doing with things, and then keep going. So they are there for you, ladies and gentlemen, if you want them. Okay? Questions? All right. Then today, ladies and gentlemen, we're going to start out with you doing this. I want names for these 5 formulas This one needs a Roman numeral in it, ladies and gentlemen. So we'll give you about 5 minutes to get that done. By the way, on your test this week or next week, ladies and gentlemen, you will have to write and name 60 formulas. That is 60 of the 70 some points on the test. Writing and naming the formulas. And then there will be some other questions on there similar to what you've seen on your quiz, and you'll see on your quiz this week as well. If you have questions while you are doing that, please raise your hand and let me know. Close.
I'm gonna listen to this when I fall asleep.
Ooh.
I want to take a picture of your little hallways, but I don't think that I just want to make
Joshua. Sorry. Okay. Kayla. Evan. Dante. Jasmine. Jackson.
Hi.
And Lucy. Lamb.
Because you can use that as a raffle ticket later. If you don't go, then you can give them your ticket and you can use that as a raffle ticket. I actually go because I have a driving lesson last night. No. No, I didn't do the test, I just had a lesson.
Okay, who's ever watching the video, either put headphones in that connect to your computer or stop watching the video while people are working on other things, please. Thank you. Kayla. Did you grab a sheet of paper for her, Michaela, or no? I didn't know. Because I saw you guys with some papers. I wasn't sure. All right. Before we go through these, ladies and gentlemen, I handed back your quizzes from last week, Friday, or yesterday if you took it yesterday. Are there any questions on the quizzes? Is there anything you would like me to clarify as far as something that you got wrong, something that you got a question about, anything on the quizzes? Now, please remember, in none of our formulas do we ever write the number 1. So if you wrote a number 1 in a formula, I marked it wrong because we do not do that. Okay? And on these formulas, now that we are into a ternary compound, if you are going to put a subscript down by a group, the group has to be in parentheses, ladies and gentlemen. Okay? Has to be in parentheses if you're going to put a subscript by it. And remember, if you are looking if we can reduce, we look at the number outside of the parentheses and the number by the other cation or anion, depending on where it is. Those are the things that you're looking at to see if you can reduce. Okay? Never changing anything in the group. Questions? All right. INHCO3 parentheses 3. All right, Michaela, go ahead. Give me the name for that one, please, if you can. Indium what? One more time, I'm sorry. Bicarbonate? Thank you, I'm sorry. I just had a hard time hearing you. And again, indium is the IN, HCO3. If you look on the back of your periodic table, ladies and gentlemen, that one is bicarbonate, okay? HCO3, it's a -1, or hydrogen carbonate is another way they will sometimes use it, okay? Questions? Jasmine, how about BaCN in parentheses 2? Barium cyanide. Okay, this one ends in IDE, ladies and gentlemen. Why does it end in IDE? Because cyanide is one of the few polyatomics that does end in IDE, okay? And by the way, I am not worried about pronunciations. You will, hopefully, as we go through this, as we do more naming and things like this, you will learn about pronunciation. I don't even guarantee that I'm saying some of them right, but it is what it is, ladies and gentlemen. So barium cyanide is that one, ladies and gentlemen. All right. SnIO3 2, and this one needs a Roman numeral. Dante, did you get this one? Tin 2 iodate. All right. So again, for this one, ladies and gentlemen, for us to get the charge, we need to do a little bit of working backwards. Iodate, what is the charge on iodate? What is it? Charge on iodate, somebody please. -1. And we need to know how many there are in the compound, and that there are 2 of them. That means this whole thing has a charge of -2. That means that the tin has to have a charge of +2 because the total charge on an ionic compound is always 0, neutral, however you wish to say it. How many tins are there in this compound? How many of them are there? 1. So what times 1 gives us a +2? The charge has to be a +2. Perfectly done. Thank you, Dante. Questions? All right. NH4 2S. Lucy, what do you got for that one? Ammonium sulfide. Perfect. Perfect. Again, this one has the polyatomic as a cation. So we name it. Because we are ending with a lone element with just sulfur, we make sure that it becomes sulfide. Okay, that indicates that it is in the compound. Questions? All right, Andy, ZNOH in parentheses 2. What do you got? Zinc hydroxide. Perfect. Questions, ladies and gentlemen? Now, the only one of these that needs a Roman numeral is tin. That's it. It is the only one. Okay. Michaela, you got to finish up your food because I don't allow eating in here. Okay. So thank you. Okay. So we don't need it with zinc. Zinc is in that area where it is a one that you cannot tell by looking at what family it's in. But because we told you that zinc is always a +2, there is no need for us to put a Roman numeral by it. It doesn't have a second charge. The only time we need Roman numerals is when that element can have a second charge. And again, I would do what I'm doing here. I would put down that you need a Roman numeral if you are going to write a name with a Roman numeral in it. I don't expect you to know which ones require Roman numerals and which ones do not. I expect you to know how to handle it when I give you one, but I don't expect you to know which ones need it. Questions? All right. Then, ladies and gentlemen, now here comes the harder part. Write 5 formulas for these names. Go, ladies and gentlemen, go. Questions, ladies and gentlemen, raise your hand. I'll be happy to come over and point you in the right direction. Which one, sir?
Uranium bromate.
Geranium, yes. Bromate. B-R-O-M-A-T-E.
Oh, I thought that looked like an E for a second.
Nope, bromate.
That makes more sense though.
Yeah.
2. You got any pictures? You have to show me one of the drawings.
All right, just a couple of things, ladies and gentlemen, before we get into writing these formulas. A couple of things that you need to be careful of. So if you're writing a formula and you're writing lead nitrate, don't do that. Don't leave a gap that you could drive a semi through in the middle of your compound. This is supposed to be together, okay? So it is supposed to be together. So make sure you are writing it together. Also, don't do this. Don't leave the charges in there. Don't leave the charges up above. When you're writing a final formula like this, ladies and gentlemen, there are no charges in it. They are all neutral at that point, okay? Now, we have used that charge to do the crisscross method, but please don't put them in anymore there. Here's another one. Well, that didn't work out very well. Don't use capital letters to represent the lowercase letter in a symbol. If you do, it will be wrong. Do not put a 1 in a formula. It will be wrong. Do not put parentheses around a polyatomic unless they are needed. It will be wrong. Okay? So these are some common mistakes that I see made. We leave way too much space. We put parentheses around it when we don't need to. Take those out. We use the number 1, okay? Or we leave charges in things so that it's messed up, okay? Or here's the other thing. Sometimes we just simply use the wrong symbol, okay? What I mean by that is people will say, all right, potassium, that's a P, so I'm going to write it with a P. Potassium is not P. What is the symbol for potassium? K. Again, if you get to know these, that's fine, ladies and gentlemen. You'll get to learn them. But for now, make sure you're not making simple mistakes, because I hate to see you do everything correct, the crisscross method and everything, but you get it wrong because you simply put down K or P instead of K for potassium. Okay? So please be careful. Questions? All right. So beryllium acetate. Beryllium acetate. Anthony, what do you got for that one? Like that? Yeah. Okay. The only thing is you missed a little bit in the formula there, Anthony. What's the formula for acetate, please? Look at it closely. Did you find it at the top there, Anthony? Yes. Okay. So what's the formula for it? C what? Okay. Oops. Hold on. I'm trying to get my pen set here. Okay. C2H3O. Okay. Now, what's the charge of beryllium, Anthony, based on where it's at on the periodic table? Positive. +2. Now, what is the charge of this acetate group that we have here? Negative. Okay. So we need to balance off those charges. So by the BE, what number would we be putting by the BE, Anthony? Okay. What about by the C2H3O2? Parentheses and a. Thank you. So we need to do that. And then, ladies and gentlemen, now we need to get rid of the signs. We need to get rid of the positive and negative, okay? Again, if you don't have to keep doing the crisscross method, if you think you've got it down and you can get the formula, that's fine. I don't know how you do it without at least putting down the charges, though, so that you see them, okay? If you can, great, excellent. All I'm worried about is, can you get me the correct formula, which is what Anthony just gave me here. Questions? All right, KP, can you give me cobalt 2 carbonate, the formula for it, please?
COCO3.
Okay. CO3. Okay, so perfect. Good. Now, what if you're wondering, CO is a +2, CO3 is a -2. If you bring them down, you could do CO2, CO3 in parentheses 2. But either Kiana knew it or figured it out that I don't need to write the numbers because they're a +2 and a -2 and their charge is already 0. No, cobalt, not copper. Okay, be careful. Cobalt, not copper. Okay, so, and the Roman numeral of 2 means it's a +2. You can do the crisscross method, but then you have to reduce these. That's how she ended up with CO3. Questions? Yes, Declan.
Aren't we supposed to show like a Roman numeral somewhere?
No. The only time we use a Roman numeral is in the name. The only reason we put a Roman numeral in the name is if we don't know what the charge of this can be. Okay? So again, we don't use any Roman numerals in here. The Roman numeral, though, Declan, is what gave us this. Okay? Gave us this charge. That's what the Roman numeral does for us. Questions? All right. Jaden, germanium bromate. All right. Germanium, ladies and gentlemen, is a +4, correct? Bromate is a what? -1. Now, I think you didn't get your crisscross here, Jaden. This is the +4. This is the -1. So what do I need to do to correct this? Okay. They give me way too big of an eraser with this thing, ladies and gentlemen. So GE, let's put parentheses around the BRO3, and let's put the 4 after it. Okay? Let's put the 4 after it. Okay? Now we've got the crisscross method. Again, crisscross, don't just bring down. Sometimes we accidentally forget that. Questions, ladies and gentlemen? All right. Potassium hydroxide. Potassium hydroxide. Mason, what do we get? No. I'm sorry. Whoa. My bad. I just told you potassium hydroxide. But what is the actual compound here? Potassium what? Hydride.
Oh.
Yeah, got to be careful. O is the correct term to put for that, by the way. Because how do we write hydride? Just H. OH is hydroxide. This is hydride. This is a binary compound, ladies and gentlemen. This is a binary compound between potassium and hydrogen. What's the charge on potassium, Mason? +1. What's the charge on hydrogen? -1. So what would the compound be, Mason? KH. Okay? Got to be careful, okay? Sometimes we get into this mindset of polyatomic, 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 and it's not a polyatomic. And hydride and hydroxide do sound very similar. Very similar. We've got to be careful, okay? Questions? All right, copper 2 phosphate, copper 2 phosphate. Oh, all right. Michaela Powers, what do you got? Okay, so copper, give me that one. Let's do this together then for everybody then.
Oh, I did do that one. Cu3 in parentheses, UO4 out of parentheses too.
Perfect. Okay. Copper, Cu, and it's a +2. Phosphate, PO4, and it's a -3. So that's where we get the 3 here and the 2 here from, ladies and gentlemen. Good. Questions? Any at all? All right, ladies and gentlemen, then here's what you have. We are going to give you about 15 minutes, ladies and gentlemen, to work on the homework assignment that is due today, which is the ternary ionic compound worksheet, ladies and gentlemen. Okay? If you're working and using your time wisely, you will get the full 15 minutes. If you're done and people are screwing around, I will move on. So again, you've got 15 minutes to get this done, 15 minutes to ask questions, 15 minutes to get with other people and work on it together, 15 minutes to get it turned in. But you have till the end of the day. That's when it's due. Okay, the clock is running, ladies and gentlemen. If you have questions, let me know. At the end of the 15 minutes today, we are going to talk about suffixes and prefixes that we add to names.
Why are you acting like I'm supposed to be?
Yes, yes. Oh, the sixth, just take it out then, I'm sorry. I made the table a little bit smaller so I think it would fit, and then I forgot to take that question off. So you don't have to put anything for that sixth one, you can just forget about it.
I just did the first.
Well, I didn't have the first row because remember, rows go across. So this was the first row, second, third, fourth, and fifth. Okay, just so we're clear. Sorry, I didn't make that very clear on that. All right, Rose, you need a charger?
Yeah.
So we give it a BLT.
You're not that dog.
Which one is it? You ready?
We just stopped that.
Okay, this is terrible Halloween music.
There's more scratch paper up front if you need it. Hey, it's number 50 on the list, so it's not supposed to be spooky. Get to work. I don't even know who this is. It's someone I've never heard of. The scary part is going to be your test scores. If you don't keep practicing. You know the correlation. What's the correlation? He told us that he used to, he has like a little river number of things. So getting back in for the scores, you just grab it. Simple. It's very and next to the point is here, but there was something. Yeah. Well, if you don't hit, if you don't aim well, you're gonna miss. If you don't aim well, you'll probably miss. Thank you. Do this right here.
I did the I would never. I mean, people.
No wonder why this. No, I didn't drive it. Yeah.
No, I just.
Yeah, you. I can have just like. Oh, okay. I missed it. Oh, I should. Oh, wait a minute. Wait a minute. Guess what shirt I'm wearing? I am Mr. Legacy.
So this is the roll. So this is the roll. That one's the roll. Yes. Roll four cross. This is proof meeting. There is no. No, I'm sorry. It's not the sixth row or anything on that section. So rolls go across.
Row.
Yes.
1, 3, 5, 7, and 9. Yes.
Okay. So this.
Well, the thing is, normally the one that is not. You think about this, this is the positive. Some of the things they have exist, but we can still make them. Yes, Rose.
No wonder why this is.
Oh. All right, ladies and gentlemen, here we go. Crazy, but since you're already there, I'll join you in a little while. All right, ladies and gentlemen. All right, write a formula for aluminum nitrite. Write a formula for aluminum nitrite and name the compound at the bottom, please.
Okay, so that's a C. I know what that lower thing is though.
Ca?
Oh, copper.
No, copper is not Ca.
I said no. You don't see. Oh, okay.
Anyone have a formula for aluminum nitrite? Joshua.
AL parentheses NO3 parentheses 3.
Okay. Anybody have a name for CaBrO4 Michaela?
That says nitrite. What is nitrite?
Nitrite?
Yeah.
Well, that's like nitrate.
That's the formula for aluminum nitrate.
Yeah, that is. That is the formula for aluminum nitrate. Now, what's the formula for aluminum nitrite?
NO2.
Thank you. Nope, you're fine. It was a trick question. Okay. So, you remember how I told you that they learned that iron had multiple charges because of compounds it was in. In one compound, it would act like a +2. In one compound, it would act like a +3. We didn't want it to be this way, but this is what we found out by looking at it. Well, here's the bad news, ladies and gentlemen. Oxygen in a polyatomic can do some weird things. It can do some weird things. Nitrate is NO3. However, we found over time that all of the polyatomics can lose an oxygen. The only thing that changes is the amount of oxygen in them. The charge does not change. The formula stays the same except it has one less oxygen in it. So they decided to call those ITE endings. ITE endings means that compared to the ATE ending, you have lost one less oxygen. One less. So, sulfite is SO3. Why? Because sulfate is SO4. But the charge doesn't change. Okay? Now, hydroxide could never do this. Why? It only has one oxygen. If it loses that one oxygen, it no longer becomes hydroxide, it becomes hydride. So, nitrate is NO3. Nitrite is NO2. Acetate is C2H3O2. Acetyte, C2H3O. We lose one oxygen. That is the only difference. The charge does not change. Only the amount of oxygen does. Chlorate is ClO3. If we lose one oxygen, it becomes chlorite. Now that is on your periodic table in the back in the upper right-hand corner. That the ITE ending means that we have lost one oxygen compared to the ATE ending. Now again, you have to know how many are in the ATE ending because it isn't always the same number. Sulfate is SO4. Carbonate is CO3. So when sulfate loses an oxygen, it becomes sulfite, SO3. When carbonate loses an oxygen, it becomes carbonite, CO2. So you lose one oxygen compared to the way it is normally written in an ATE ending. Fair enough? Okay. So what has happened here? We have gained one. You could gain an oxygen. Look at the back of your sheet. What do we do to the name when you gain an oxygen? We add per in front of it. So what is Ca? Calcium per bromate. So because we have gained one oxygen, we put a per in front of the polyatomic. We lose an oxygen, it becomes an ITE ending. We gain an oxygen, we put a per in front of it. Questions? Now, more than that can happen, ladies and gentlemen. We could put a hypo in front of an ITE ending. Now, an ITE ending already means what? That you've lost one oxygen. If we put a hypo in front of it, it means that you have lost a second oxygen, or one more compared to the ITE ending. So polyatomics that contain oxygen can have varying amounts of oxygen. Therefore, we need different names for them. Now, we didn't want to change the name completely. So what we do is we add a prefix or a different suffix to it to change it slightly. If you lose one oxygen, you become an ITE ending. If you were to lose two oxygens, so now you went from NO3 down to NO, lost two oxygens, we would put a hypo in front, and we already have the ITE ending because we lost one oxygen. So you may lose one oxygen, you might lose two oxygens, or you could gain one. Those are the three things that can happen, okay? Now, can acetate lose two oxygens? No. There still has to be oxygen there, okay? So acetate cannot lose both of those oxygens and become hypoacetate, okay? Because there's got to be oxygen in it for that to happen, okay? Hypo is a prefix that means one. Why does it say more? It means, oh, we lose one more. Sorry, I was reading it wrong. I'm glad you guys are paying attention. Hypo is a prefix that means we lose one more oxygen compared to the ITE ending. The ITE ending, we lose one. Hypo in front, we lose two. Okay? So that's two less than the ATE ending. So, nitrite, NO2, becomes hyponitrite when it is NO. By the way, I have the 1 here, but would we write it? No. I just put it here so that you can see that there's only one of them there, that we have lost a second. In the formula, we would not write this one. Carbonite, CO2, becomes hypocarbonite when it becomes just CO. Okay? Now remember, this is still an ion. It still needs to attach to what? What does this ion need to attach to? In our compounds, we always have a what and a what? In what? Cation and anion. What are all of these? These are all anions. So this still needs to be attached to a cation. Very good. A metal or a cation. Okay? A metal or a cation, either one. Okay? Phosphite, PO3 becomes hypophosphite at PO2. Chlorite, ClO2 becomes hypochlorite at ClO. Again, we're losing 2. It's not that we're going down to a certain number. This one has 1, this one has 1, this one has 2, this one has 1, this one has 2. It's a matter of how many we are losing. Okay? Sulfite can become hyposulfite if we go from SO3 to SO2. By the way, these have already done what? The IT ending means they have already done what? Lost 1. So nitrate is NO3. Nitrite is NO2. Hyponitrite is NO1. Carbonate is CO3. Carbonite is CO2. Hypocarbonite is CO. Phosphate is PO4. Phosphite is PO3. Hypophosphite is PO2. Chlorate is ClO3. Chlorite is ClO2. Hypochlorite, ClO. Sulfate is SO4. Sulfite is SO3. Hyposulfite is SO2. Questions? Okay. Still need a charge of 0. Okay? Still need a charge of 0. So we are still going to do our crisscross method. By the way, even though there's no number by the NO, what do I do if I want to put a subscript by this group? Still put it in parentheses. We still need to put it in parentheses. So the 1 comes down by the BE, the 2 comes down by the NO2. We leave the parentheses because we're going to leave that 2 there, ladies and gentlemen. This is no different when you're writing a compound. We are still doing the crisscross method. We are still reducing into lowest terms. And we are still putting our polyatomic in parentheses if they are going to have a number by them. Questions? All right. Aluminum, a +3. PO2, which is what? What is PO2?
Hypophosphite.
Hypophosphite. Hypophosphite. We're still going to do the crisscross. We end up with a -3 there and a +3 there. Now again, I hope you realize I'm going to drop the signs for sure here. I'm just showing you we brought this down by the aluminum. We brought the +3 down by the PO2 group. We can reduce these because 3 and 3 can be reduced. So we end up with AlPO2. Aluminum, what? Aluminum hypophosphite. We're still naming the same way we did. We're not changing the name of the polyatomic once we figure out what prefix and what suffix it has. Reduced form there. All right. So we write the name of the cation. What's Be? Beryllium. What's NO2? I'm sorry, NO. Sorry, my bad. NO.
Nitrate.
Well, NO3 is nitrate.
Nitrate.
This has lost how many oxygens?
One.
Try again.
So hyponitrate.
Hyponitrate.
2, hyponitrate. Hyponitrite, sorry. Okay? Now remember, this 2 is outside the parentheses. It is not NO2, it is NO and 2 of those groups. NO3 is nitrate. NO2 is nitrite. NO is hyponitrite. Questions? So what do we got here?
Lithium.
Salt.
Okay, ask yourself, what is the normal group with S and O? SO what? The normal group on the back of your periodic table. Sulfate, which is SO4. How many oxygens did we lose here?
2.
So,
Lithium hyposulfite.
lithium hyposulfite. Hypo always goes with ITE, ladies and gentlemen. You cannot lose 2 oxygens until you have lost 1. So when we lose 1, the ending automatically becomes an ITE. Losing the second one puts a hypo in front. Okay? Questions? All right, so the per. And again, all this is on the back of your periodic table, ladies and gentlemen. I am not expecting you to memorize it. I am expecting you to be able to know how to use it because it is on the back of your periodic table with examples there. The per ending or the per beginning always goes with the ATE ending. Okay, again, why polyatomics that contain oxygen can have varying amounts of oxygen. Therefore, we needed different names. The per for a prefix means we have gained 1 oxygen compared to the ATE ending. That is why per always goes with 8, because we are gaining 1. Okay? Per can never go with an ITE ending because it would put us right back at the original ATE ending. Okay? So, nitrate, NO3, becomes pernitrate, NO4. Carbonate, CO3, becomes percarbonate, CO4. Phosphate, PO4, becomes perphosphate, PO5. Chlorate, ClO3, becomes perchlorate, ClO4. Sulfate, SO4, becomes persulfate with SO5. And again, 4 oxygen, 4 oxygen, 5, 4, 5. It is based off of how many oxygens were there, not a certain amount of them in the end. 1 more than the ATE ending. 1 more than the ATE ending. Question. Okay. So here's the nice part about the formulas, ladies and gentlemen. We are literally not doing anything different than we have been doing since we did binary compounds. We are trying to create a compound that has a total charge of 0. We are still doing that here. And whether this is BeNO, BeNO2, BeNO3, or BeNO4, NO2, NO3, NO4, NO all have a -1 charge. So it does not matter which one you are using. The compound is going to end up being very similar. -1 comes down by the Be, plus goes down by the NO4. Now it becomes BeNO4 with the 2 after it. Why? We're putting a subscript by a polyatomic. We have to put it in parentheses. Okay? What is the name of that? What is Be? Beryllium. Beryllium pernitrate. Beryllium pernitrate. Again, same compound we did a minute ago with a PO2. Now we're at a PO5. Its charge doesn't change. So when we do the crisscross, we still have a positive 3 by the PO5 and a negative 3 by the aluminum. That means these can still be reduced, ladies and gentlemen, down to AlPO5. The only thing that we are changing is the name on the polyatomic. Is the name on the polyatomic. So again, this one, beryllium pernitrate. What would this one be? Lithium persulfate. Lithium persulfate. Okay? So, just so you know, ladies and gentlemen, there are a ton of different ways of having a compound. So let's take a minute here. Oh, that's not the one I want. This is. All right, give me any polyatomic that ends in ATE with oxygens in it. Okay, we'll do phosphate. Thank you. Good choice. All right, if we gain an oxygen, what does it become? By the way, it's a -3. What would it become if we gain an oxygen? What would the formula be? PO5, still a -3. That is a 5. What would the name be? Perphosphate. Sorry, running out of room there, ladies and gentlemen. What if we lose one oxygen? What does the formula become? PO3, and it's still a -3. Now it becomes phosphite, ITE ending. Okay? Now, what would it be if we've lost 2 oxygens? PO2, still a -3. I'm going to put the name down here so you can read it better. Hypophosphite. By the way, what's the formula if there's no oxygens? What's its charge? -3. What would the name be? In a compound, sorry. Phosphide. It's going back to writing a binary one. That's going back to writing a binary one. Okay? So we could do this with every one of them, ladies and gentlemen. Please remember, if there's no oxygen, those are the ones that we were doing before. Phosphorus becomes phosphide. Sulfur becomes sulfide. Nitrogen becomes nitride. All lefty, ladies and gentlemen. That was a good day today. That was a good day today.
Oh, he's okay with that.